Shit, what is
My
it?
earphones
You can crop
not
it.
working.
Bro, something is recording, bro. I don't know.
Wait, I'll come.
Everyone
1 second. Give
has
me
their
one
own
second.
problem in their life. Record ಆಗುತ್ತೆ ತಾನೆ.
Can you
Everywhere
hear my
record ಇದೆ
voice
ತಾನೆ?
clearly now?
Yes, Neha, it's
No.
It's heard, right?
yeah, it's properly heard.
Put these earphones.
Yeah, okay, I'm ready.
Is from starting of the PPT slide.
No.
Uh, okay.
Huh. Guys, let's rock this
And
time.
unmute.
Come.
Yeah, come on, guys, we can do it. And unmute it, okay?
Okay.
ನೀನ್ ಮ್ಯೂಟ್ ಅಲ್ಲಿ ಇಟ್ಕೊ.
Tell me when to start, I'll start.
Start, bro. Start.
3,
Hello
2,
everyone, this is Apurva, and today I'll be talking about regenerative braking in electric vehicles as a part of our experiential learning. Okay. So I'll be talking about what is regenerative braking system. When a vehicle with conventional braking system applies its brakes, kinetic energy is lost as heat energy as a result of friction between the brake pads and the wheels. And this heat is carried away in the airstream, and the energy wasted or lost depends on how often or how hard the brakes are applied. So, regenerative braking is basically a unique technique that is used in EVs to capture energy that the vehicle has lost due to its motion, or in other words, the kinetic energy that would have been wasted when the vehicle decelerates. So we'll talk about the regenerative braking mechanism now. This is a rough diagram of regenerative braking system given above. So while driving a vehicle with a regenerative braking system, the electric motor draws power from the battery and creates the kinetic energy it needs to in order to move. But when the brakes are applied, the process switches into a reverse mode. Now the kinetic energy that was used to propel the vehicle or move it ahead makes the vehicles rotate the electric motor, turning it into a type of generator. So instead of consuming electricity, the motor or the generator starts producing it. That is, it uses the vehicle's kinetic energy. The electric energy that is generated by the generator is then stored in a high voltage battery, where it is again used to move the vehicle. uh, since the vehicle since the regenerative braking converts the kinetic energy into electricity, it is able to slow it too. Now my friend will talk about what is an EV battery and its application in regenerative braking system.
I am Vibha Shrestha and I will be speaking about the topic EV battery. As we all know, EV battery plays a very important role. It is also known as rechargeable batteries or secondary batteries, which provide a viable means of strong electricity to the electric vehicles. And this was invented by a French physicist. And here, the lead acid battery or the lithium battery plays a very important role. Next slide. Next slide. EV batteries in electric vehicles or a traction battery can either be primary battery or a secondary battery. These are mainly rechargeable batteries or secondary batteries, and it was first invented by the French physicist. And here mainly the lead acid battery or the lithium batteries are used. Next slide. So the types of EV batteries, we have lead acid battery, nickel metal hydride, sodium battery, and lithium ion battery. Now I'll be speaking about the lead acid battery. The lead acid battery consists of two types of electrodes, which are submerged in an electrolyte of sulfuric acid. So the positive electrode is made of grains of metallic lead oxide, while the negative electrode is attached to the grid of metallic lead. And the lead acid batteries are classified into two different types, mainly the flooded and the wall regulated. So now the sodium battery. So sodium battery is also known as NIB or SIBs. Is a type of rechargeable battery, where the lithium ion battery, by using here instead of using the lithium ions, the sodium ions are being used. So the working principle here is that the cell construction are almost identical with those of commercially widespread lithium ion battery types, but the sodium compounds are used instead of lithium compounds. And now we talk about the lithium ion batteries, where it is also a type of rechargeable battery composed of cells in which the lithium ions move from the negative electrode through an electrolyte to the positive electrode. And here during the discharge, and when the lithium ions use a lithium compound as the material at the positive electrode, and typically the graphite at the negative electrode. So here the lithium ion batteries have high energy density and no memory effect. So cells can be manufactured to prioritize either energy. They can, however, be safety hazards since they contain flammable electrolytes, and if damaged or incorrectly charged, can lead to explosions and fires. Next slide. So some of the smart function of lithium ion batteries are as follows. So we have Bluetooth capable, efficiency energy use, fast charging and low self discharge rate. So here the question comes is why always the lithium batteries are used. So some of the important reasons are as it keeps the battery working in optimal condition, prevents thermal runaway and fires, shuts your battery off when a problem occurs to prevent any kind of damage. Next page. So relevant standards in lithium ion batteries are battery parameter detection, we have online fault diagnosis, we have a balance control of battery cells, network communication, and charge control. So I would be speaking about some points here. So, in network communication, the BMS needs to communicate the network nodes such as vehicle controller. At the same time, the BMS is inconvenient to disassemble on the vehicle. So, hence, it needs to be online calibration where the monitoring, automatic code generation, and online program should be downloaded so that the general vehicle network adapts a proper technology. So here and next we talk about the information storage, where it stores specific data keys such as SOC, SOH, SOF, and SOE, which are accumulated charge and discharged. So the real BMS in the vehicle may only have some of the hardware and software, and each battery unit should have at least one battery voltage sensor and one temperature sensor. So next is electromagnetic compatibility, where due to the harsh operating environment of electric vehicles, the BMS is required to have a good anti-electromagnetic interference capability. So at the same time, the BMS is required to have low external radiation. Next page. So here the main task of battery management system is to ensure the proper designing function of the battery pack system, which can be further broken down into three following aspects: the safety, durability, and power. So the safety is all about to protect the cells or the battery pack from the from damaging or any kind of accidents, and durability is to make the battery pack work within the reliable and allowable range and extend the service life of the battery pack. Third one is the power, which is used to maintain the battery pack to power in any state that meets the requirements of electric power vehicles. Next slide. Some of the problem detection and prevention is that very fast loose connections, short circuiting, defective battery cells, wire insulation breakdown, and defective battery fan. Next slide. Next topic will be taken over by the teammate.
I'm Aishwarya. I'll be talking about the microcontrollers. A microcontroller is a complex circuit design which performs specific operations. A proper microcontroller consists of a processor, memory, and input output peripherals on a single chip. It is also called embedded controller or a microcontroller. They are mainly found in home appliances, medical devices, robots, etc. Next slide. Now, talking about the need for microcontrollers in electric vehicles, we have increased demand for safety, comfort, efficiency, and to this in the automobile makes to introducing microcontrollers. A microcontroller is an automotive can control the anti-lock braking system, tracking control, injections. Next slide. Talking about the MOSFET. With the low speed of BLDC motor, the winding back EMF cannot reach the voltage across the battery. Recovery of the energy also cannot be achieved. Because of the presence of the inductance in motor windings, these are continuous to the boost circuit. To achieve recovery of energy, we have to raise the voltage through inductor accumulator. We turn off the MOSFET on high arms of high H bridge and is controlled on the low arms of H bridge with PWM. By controlling MOSFET, the whole circuit constitutes a boost circuit. Next slide. From here, my teammate will continue.
I'm Neha, and I'll be talking about fuzzy logic in regenerative braking. Sometimes we cannot decide in real life if the given problem or statement is either true or false. At that time, fuzzy logic concept provides many values between the true and false and gives the flexibility to find the best solution to that problem. In the Boolean system, only two possibilities exist, where 1 denotes the absolute truth value and 0 denotes the absolute false value. But in the fuzzy system, there are multiple possibilities between the 0 and 1, which are partially false and partially true. So, definition of fuzzy logic is it is an approach to computing based on degrees of truth rather than the usual true or false Boolean logic on which the modern computer is based. The fuzzy logic can be implemented in microcontrollers used in electric vehicles to increase braking efficiency and also for better energy recovery. Next slide. Now I'll briefly talk about four main components in fuzzy logic system. The first component is rule base, which is used for storing set of rules. The if-then conditions given by the experts are used for controlling the decision-making system. The second module is fuzzification, which converts the input variables into fuzzy steps. The inputs measured by the sensors are sent into the control system by this module for further processing. This component divides the input signals into following states, which are high, medium, and low. The next component is the inference engine. It is a main component in the fuzzy logic system because all the information is processed in the engine. It allows users to find the matching degree between the current fuzzy input and the rules. The final component is defuzzification. It is a module which takes the fuzzy set inputs generated by the inference engine and then transforms them into a crisp value. The crisp value is a type of value which is acceptable by the user. So, talking about the application of fuzzy logic system, it is used in automotive system for speed control and also for braking system. Now, let us see how fuzzy logic can be implemented in braking system. Next slide. Taking into consideration the influence factors of regenerative braking, we have two inputs. The driver's required braking force and vehicle speed, and the output is the ratio of regenerative braking force to the total braking force. Fuzzification module component converts these input variables into fuzzy steps, and inference engine processes the data and provides output. In electric vehicles with fuzzy logic controllers, fuzzy rules can be written according to the requirement. This controller is used for braking force distribution between the front and rear wheels of electric vehicles for smooth braking. The brake requirement of a driver and the safe driving are also interconnected. So, how it works is when a large braking force is applied, it means the vehicle has to be stopped immediately. In that case, the proportion of regenerative braking force has to be reduced. When braking force is intermediate, the ratio of regenerative braking force can be increased. And also for small braking force, a large regenerative braking force can be applied so that maximum possible energy can be regenerated. Vehicle speed also plays an important role in braking safety.